All right. Thanks, everyone, for coming to the session. My name is Mengliao. You can also go by Mike and from Geotab. And today I wanted to walk with you to the journey that we have been through to optimize our video AI inferencing and operations at Geotab with Anyscale Ray. So this is a bit about agenda that I'm going to go through. So first, I'll give you a quick introduction about Geotab, what we do, and our cameras, and our journey with Ray, and also the challenges we have run into on the video-specific problems and how we resolved it, and like the challenges in the designing the architecture and how we gone through the evolution about different phases. And eventually, I'll finish with some key takeaways and the future direction and come up with a Q&A session. So first introduction to Geotab. Not everyone in the room probably knows about Geotab. So we are a global leader company in the telematics industry. We are mostly focusing on connecting the vehicles and the assets into the fleet management. We have over 5 million devices across the whole worldwide. And so the basic idea is that we provide the core assets as a Go device, what we call it. This Go device can be plugged into any vehicle and using the OBD2 port. So the moment you plug it in, very easy, you don't need extra setup. Like it's gonna collect all the metrics about your vehicle GPS, location, and acceleration, the engine status, about the speed, all kinds of information on the telematics company and telematics data. Then those data are kind of just on the telematics side. And we are kind of a technical-driven company where we have a lot of engineering culture and the data-driven culture as well. We kind of help to optimize the safety side of things for all the fleet truck drivers. And as a bit of overview on the company, we are celebrating the 25 years anniversary this year, actually. We have over 3,300 of Geotabers, and we have 700 partners globally and over 100,000 customers across over 20 different countries, and actually 160 countries for the customers. We have over 5 million device subscription. That means we have 5 million devices running on the road, and about 100 billion data points collected on a daily basis. So the biggest reason that brought us into the camera and the video side is because telematics data only tell us what happened to the vehicle, but not to the outside of the vehicle. For example, the driver can have a harsh brake, but we don't know what's really the reason he had a harsh brake. Or he was speeding over the speed limit, but we don't know really the reason behind it. Maybe he's careless. Maybe the speed limit that we have labeled from Google Maps or Here.com is incorrect. So the only way to have authentic, like the right single source of truth is to have a camera, dash cam, installed on the vehicle. That's why we introduced the first generation of Geotab camera, AI camera called Go Focus in February this year. So Go Focus has the machine learning model installed in the camera itself and able to do some edge device calculation, and also is able to collect the video, record it, and upload to our cloud service and doing some cloud model inference as well, and to help the driver to build a better safety features and other maintenance and features as well. And the next generation of Geotab AI camera is called Go Focus Plus. As you can tell from the name, it's the next level of the Go Focus camera series. So it has a better performance, and better chip, and also has both a front-facing and inside-facing cameras. So it can also, instead of measuring what's outside of the vehicle, can also see the camera, can see the face of the driver. For example, if the driver is picking up the phone, checking the messages while driving, the camera is actually able to do the voice coaching in time, telling the driver, put down your phone. And the driver can actually kind of do a lot of things with that. And we have seen the driver want to challenge the camera, saying, I didn't pick up the phone, you have done something incorrect in your model prediction. So this is kind of unlock a lot of possibility. The biggest thing is the coaching, like the driver coaching, which has been a focus on the fleet companies, fleet managers. They want to know who are the good drivers, and the most important thing is that for the bad drivers, how to get them improved, reduce the risk of collision in the future. And also, we have evolved the whole AI ecosystem about not just like doing the video on the edge device. We want to take further into some future possibilities that which I'm going to cover later on. So this is the big step in Geotab that we announced in September. Ever since September, we have seen great adoption from the customer, actually much more faster adoption that we have seen and great feedback overall, which motivated us to build more amazing stuff with it. So before I actually get into the problems, how to solve the technical side of it, so first is our journey with Ray. We started prior to 2024, October, doing some internal POC research experiments with open source Ray. Because we are kind of mostly on the Kubernetes side. At the time, there's not an Anyscale operator being released, so we kind of just use a kube Ray to play with it. 2024, October, we went to the first Ray Summit. And we were like blown away from all the talking sessions from different companies, different organizations. We talked to many industry leaders, and we got a great understanding of how things are going. And so in December, we invited Anyscale on site to Geotab offices. We had a lot of the trainings and design meetings and architecture talking, technical talking. And in 2025 March, we built the first POC ready for the video post-processing application, which does decoding, transcoding, face blurring, license plates on the cloud side, not on the edge. But it does a lot of things, and that we were running previously on Kubernetes natively without any like a framework on top of. And then 2025 May, this application has been running in production. And so far, for 6 months, we haven't even received a single production issue. It has been very stable for the application. And in September, we have the first full end-to-end computer vision model that's actually on the edge device running in Anyscale Ray. So end-to-end means from model experimentation, training, tuning, testing, file conversion, deployment, running, et cetera, all in one place in Anyscale Ray. And after talking about the journey, I'm going to cover about the actual problem. It's not that easy as you might thought of. So one of the biggest challenges is that when we are running a model on the camera, typically it's written in C++ and to get the best performance on the edge device. You rarely run the Python code natively on the camera. And also the model was already built before we got onto Ray. So the biggest challenge is that how to refactor these existing Python code, and most importantly, is the C++ code to run effectively and efficiently on Ray. And the second problem we ran into to measure the consistency across the cloud and the edge environment. Obviously, you cannot use a camera to do all the testing. And you kind of have an emulator to test that, but also you want to make sure they are producing the same result from both cloud and edge device. And during the whole model end-to-end workflow, there are manual tasks everywhere, like doing the training, doing the regression testing, doing the model registration, doing the deployment. All kind of things are being manually done by the data scientists, which is not great for their time efforts. And the collaboration across teams, we have so many different teams that are kind of working on different projects, like GoFocus has a team, GoFocus Plus has a team. We have other team doing the LLM stuff, and we have a team on the MLOps side. We have this team that's building Array and maintaining it, and other systems like MLflow, Airflow, etc. So how to get all the team to collaborate efficiently without one team dependent on other ones waiting for them to get it done is a big challenge as well. And the frequent performance testing, regression testing, and the consistent testing is also a big challenge. Performance testing makes sure like the model is able to process the videos at a certain frame per second rate. And the regression testing means like a typical validation test in the traditional machine learning world, but kind of we run the huge data set covering all the different scenarios, like snowing nights and raining days, etc., to make sure it's able to perform well on all different scenarios. And the consistent testing, as I mentioned, just measure the edge and cloud device, make sure they're the same result. And lastly, but not least, is the data privacy and the compliance side. As we are getting the videos and recorded, it has a lot of personal information, especially with the inside forwarding, inside-facing camera. The video contains the driver's face, and outside going is also containing a lot of pedestrian and other people's face and the license plate, etc. And we need to make sure they are compliant with the GDPR and the other AI Act, and to make sure they don't get leaked out or hacked by or accidentally downloaded by employee or customer. So before we get into the actual solution, there are some high-level Ray design decisions that we have to make, mostly driven by the problem that we mentioned, and those had to be made at the beginning. The three major problems that I'm going to cover today. So the first one is Kubernetes versus VM. It's an obvious choice, and to us, Kubernetes is widely adopted and the preferred or opinion option at Geotab. Most of the data platform and AI platform services are already built on Kubernetes. We have Kafka, for example, MLflow, Jupyter Hub, Airflow. They're all based on Kubernetes with Istio. And if we have Ray running on Kubernetes, it will be a lot easier to have them integrated with existing setup and infrastructure. But the VM solution do have one major significant improvement is the job start time and the node start time. So typically, it's like 1 minute versus the 5 to 7 minutes on Kubernetes. So we did a lot of improvement, as we're going to mention later. So eventually, and also as the Anyscale operator was released in the late 2024, it became kind of mature after a whole year. At the beginning of the phase, we are kind of the early user of Anyscale operator. It did have some issues at the beginning, but kind of getting resolved. But so far, everything has been running well. We are using Kubernetes as the final result, and everything has been working so far. The second choice is about running the C++ code. So typically, there are two solutions. One is the subprocess, one is the pipeline. So we were debating between that. So the subprocess, the obvious benefit is that it makes it a lot easier to migrate existing code. You don't have to like convert it into a Python code. You just kind of wrap it up and as executable and just run it behind a Python subprocess. And allow the Python code and C++ code to be loosely coupled so you can make changes in one side without really heavily impacting the other side. But the biggest problem is that the pipeline offers a much lower overhead comparing to the C++ on the subprocess. And the troubleshooting will be a lot easier over there. And eventually, due to the time constraint and the timeline that we have, we went with subprocess. So far, the performance is not a big concern to us. We have seen everything working well. But eventually, we're going to consider these two options for new models that are coming up and ongoing basis. The last one is the Git repo structure has been a common topic for every team probably running on Ray. And it's about how do you construct your code repo. Typically, two ways. It's a mono repo that everything is in one Git repo. The other one's multi-repo, kind of a microservice. Each service has its own repo. Both have its pros and cons. Everything is a trade-off. And so multi-repo gives the team more autonomy and to reduce across-team dependencies. However, the mono repo can improve a lot of code reusability and give one centralized CI/CD pipeline to allow the one central place to do the security governance and the controls, access control, and like vulnerability scans and many other things, and you don't have to register and repeat them every time you set up a new project. So it's a hot debate over there. Eventually what we went with is kind of a mix of both. So we kind of go with a mono repo for a team basis or on the product basis. For example, GoFocus can have its own mono repo, have everything in there, but the GoFocus Plus will have its own mono repo, etc. in that way. And we are kind of working on that. And we are still kind of debating and evaluating how things are going to go. But this is what we are currently going with. So let's get back to the original problem. Like if you look at the challenges, a lot of them still are not resolved by the high-level decisions, such as the collaboration, like the manual task. And coming on to the rest, what else is missing? So it's kind of a really big topic. Instead of coming down to detail, we need to think from a high level about a centralized machine learning platform or just a machine learning platform. Like it's supposed to handle all these problems, but now we see all the current machine learning platform provided by the vendors are kind of onto two categories. One is the open sourced, but the specialized platform, like MLflow, like Airflow. Those are the things that, and Ray, actually, they have very deep features into the product. And it's highly customizable. It's great in some domain, but they don't do the whole end-to-end, typically. You need to integrate everything together to get a full experience of the end-to-end machine learning operation. The second one is a closed but end-to-end platform, like Vertex AI, like SageMaker, like Databricks, and many other ones. They are great, and they are a lot of teams that actually, some of our team members have been using them as well. But proprietary, that's the biggest problem, that they don't allow you to customize for your own purposes. For example, integrating with your own company internal systems is going to be very difficult a lot of times. And the features provided there are not on the same level as open source ones sometimes. So it comes to our question, we have been asking this question internally many times, like why there's not one solution of the market for everything. So I think everyone knows that we have a huge difference across teams, across companies about the preference of a developer and data scientist. Even within the same organization, you will see different developers and data scientists will have different preference. And it's also in terms of the size and the nature of the model and the infrastructure, like Kubernetes versus VM, like GCP versus AWS versus Azure. All these kind of questions are going to be very different from different organizations and teams. And even in the business value and the process and security control, privacy management, all these things are very different. So make it, like, basically makes no sense for one company trying to build one-for-all solution. The ones who try to build them always kind of run into different issues that burn out of them energy, just basically eventually turn it into a highly customized solution that doesn't work for all. So eventually we decided that at Geotab, we need to have our own solution, which is not a heavy-duty task, but is something lightweight that can connect all the components we have and make them easily plug in, plug out something. And the most important thing, connect all the teams together to collaborate in this one environment. And we can customize for our own requirements. And here comes the Geotab Model Management Center. We call it MMC internally, easy abbreviation. So what it does is a very lightweight kind of a service that we automate the workflow from training to testing, validation, deployment, monitoring that we mentioned. Everything is automated, so removes the manual tasks. We provide also Geotab-specific requirements and functionality, such as our own model card, our regression testing, our model file conversion between the edge device and the cloud model, and also A/B testing, etc., which are not out-of-box from the open source one or the vendor solutions. And we use it to integrate Ray with other systems like MLflow, Geotab Jupyter Hub, like Airflow, etc. And we provide a UI interface so all the team members can log in into one place to collaborate, to verify the result, approve the model to production, review the model code configuration, etc. And improve the team collaboration, entire model lifecycle in a much better way. Here's a quick kind of screenshot just to show you what it looks like. So you will have some basic model metadata, for example, the name, the product name, what product tied to, the tags and the status, and created by who, and the deployment. And here is the kind of a rich text and some images that can be uploaded to the model card. That's kind of a Geotab own specific model description. And then over here, we have some tabs that can show you the regression pipeline that the version has been deployed to. And even some privacy information can be tracked here. So security and privacy team can come to the same place, review, does it have a PI, personal identifiable information? Does it have a PIA? What is the privacy assessment result, etc. So these kind of things are the ones that we are managing, use it for the team, and the MLOps team can come over, approve it to deploy to production, and they can view the monitoring result that has been alerts being generated all in one place. That's kind of the whole idea. So after we talk about that, so we come into the architecture side. So before we have Anyscale Ray and also the like the MMC come into play. This is the old days that our data scientists are doing their job. So basically, they will write the code that's doing the training. They will download that from Git repo to either Jupyter Notebook or their personal laptop. And they run the training. And once they've done the training, they write the model into MLflow with the model registration. But it doesn't go anywhere from MLflow. It's kind of just for reproducibility. And then they do the testing of the model using the test data sets hosted on GCS bucket, manually downloaded to the notebook or local laptop. Then do a file conversion into the edge device, then run a regression testing somewhere using a different data set. And then eventually when they say, I'm ready to go to production, I want to deploy it, you have to deploy on QPod, on Airflow that we already have. And so that's kind of a QPod, as we know, is not optimized for machine learning workload. It cannot use, or it's hard to use a GPU configuration for it, and it's not the best way to maximize the CPU or GPU utilization for long-running jobs. So, and the laptop obviously is not the best choice for training a model either. So that comes to the new AI architecture platform that we have incorporated the new system that's highlighted in the red color, basically are the MMC and Anyscale Ray. So the new life cycle is like this. The data scientists will still have the model application code, the model code they run somewhere, save it on the GitLab, and save in the same model repo with the DAG code, with the Ray configuration, etc. It's going to be pulled over to the Jupyter Notebook, and it's going to run doing some experiments, and the model is going to be saved on the ML flow. Actual training, I didn't draw the line, but it's coming down to the Anyscale Ray training. The Anyscale Ray training will generate and collaborate with ML flow. But eventually, once the model is generated in ML flow, it's going to be sent over automatically without anyone need to do anything other than clicking button. Is going to be automatically populated in the model management center, which can have all the configuration data scientists want to have. For example, my regression test, which data set I'm going to use, and what is the Docker image I'm going to use, and the Airflow configuration, and the Ray service configuration, the YAML file, and the edge model configuration, how it's going to run. Everything in one place that you can, Airflow can go ahead and put it out, Anyscale can go ahead and put it out, the configuration to run it. And the whole life cycle about training, testing, file conversion, regression testing are happening on Anyscale Ray now instead of on the computer laptop from the data scientist. And also the serving is now moved over from the queue part, from Airflow, to be a service or a job in Anyscale and Ray. And we have the Airflow DAG actually making an inference to the Ray job or Ray service. And the files are still saved in GCS bucket, but instead of using a personal GCS service personal account to access, they will be using the Anyscale service account to access, and some of them using Google PubSub to do the notification in like the real-time production videos. So with this new architecture, we can get a lot of better things to happen and a more secure way. And we also made some other improvements. Those are not the fundamental architecture. For example, we have a static persistent disk containing the whole video data set. We found it to be much faster other than using the GCS bucket attached to the Go Ray jobs. And also, we have a centralized reusable regression test pipeline that whenever a new model comes up, they don't need to build it from scratch. You can reuse it. And we have built a clear segregation on Git code owners, so each team can have their own responsibility about who to approve it, who to write it. We have built the monitoring and the alerting side on the video storage, so anyone who is attempting to download the video outside of the specific domain and the region, they will get alerts so that can protect the security team and to get them in to protect like legislation and the compliance level requirement that we have with our customers. And most important thing, we build SOP for the on the machine learning model development lifecycle, utilizing the new architecture. And as a result of this adoption, we have some major wins across the board. You have heard some of them in today's keynote. So first, we have one centralized platform for all the job and services, governance, and observability in one place. We have removed most of the manual efforts from experiment to serving in production. We have improved the code quality significantly by refactoring the legacy code to Ray jobs and Ray services. And the QPS for the video processing has been improved by 43 times at the peak hour. And the GPU utilization has been improved from around 10% to 50% at peak hour as well. And amount of GPU required to support this Ray service has been reduced by 40%. And those are all the major contributions by the team and the Anyscale team, which I'm going to give a shout out to. We had a lot of features. These are just some top ones I selected from our backlog that got completed. Some of them are still in the progress, some of them are still in the backlog, but we have a long list of that. And Anyscale worked heavily with us. They spent countless hours that's on doing the chat on Slack, doing the troubleshooting, doing a sync-up meeting, doing the code example with us. So really, we cannot achieve everything we have here without Anyscale support, and it was been a really great experience working with the engineers over there. Oops. So finally, I'll give a quick future map on what we're going to do next. So after we wrap up everything we're working on today, we are going to look into utilizing Ray as a centralized model training and the inferencing platform for other non-video machine learning areas. For example, the deep learning models that some data scientists are working into, some of the traditional machine learning models that do not require GPU, some open source LLM fine-tuning, and the self-hosting that we are already experimenting right now, especially on the using the LLM to do the video inferencing. That's something we're looking at. And also, we are looking to build a machine learning model monitoring system. Like currently, we're using Apache Superset, which is our kind of internal BI dashboard tools. But we are using that to be the temporary solution for the machine learning model to see the metrics and the engineering metrics and the model accuracy performance metrics. But eventually, we would like to have one that's kind of a best fit for machine learning model workloads. And also, we are looking to automate the retraining mechanism for the model that's deployed, running in production. We want to see to be able to detect the data drift or performance degradation, and eventually look at the possibility of automatically re-trigger the retraining. And we also want to further optimize the node and job start time, which we already work with Anyscale, brought down some of them significantly from 20 minutes to less than 5 minutes. That's something already happened, but we want to further optimize to see if there's opportunity to do that. And we want to allow data scientists to troubleshoot more efficiently on the local machine, on their laptop, instead of on Anyscale workspace. They are using workspace, they use Jupyter Hub, but we want to see what's the best way for them to even use a laptop. So those are all the things that have been planned on. And here come to the end of the session. Really thank you everyone for coming, and I'm open to questions.
Super cool, thank you, Mike. Maybe 1 or 2 questions from the audience.
So you mentioned Anyscale operator, and whenever you're talking about Ray, you mentioned Anyscale Ray. So I'm a little confused by this concept. So first, when you talk about Anyscale operator, are you talking about Ray operator? And second, are you using Anyscale platform, or you just integrate Ray into your own platform?
So Anyscale operator is the enterprise version of Ray. So Ray has an operator, which is open source one. Anyscale last year in the Ray Summit, October, they announced the Ray Anyscale operator, which is basically their own version of like operator on Kubernetes. And so we are not running open source Ray. We are running the Anyscale enterprise Ray, but we are hosting like the Anyscale Ray, basically the Ray, but not open source one, like a Ray Turbo in our own GKE cluster, Google Kubernetes Engine. And we connect to the Anyscale cloud platform, just mostly for the metrics to display the log, to kind of use the RBAC and everything they have for authentication authorization, but the execution and the computing are happening on our own GKE cluster. Yeah.
Cool. So I think you made the distinction between having your video data set, your like entire video data set, and then the video data set that lives on GCS, like your production video data set. Is that a distinction?
Sorry, are you can you kind of repeat it?
Yeah, so is there a distinction between like your entire video data set and then your production video data set? Because I think you said you kept one on GCS and one separately on a persistent disk.
Yeah, thank you. So basically, we have 3 data sets, and so training, testing, and validation. So training are the one obviously used for training, testing is for quick testing. Validation is not visible to data scientists. They are just kind of automatically run after the model being pushed before go to production. So those ones are kind of already occupied, downloaded, labeled by like some within the organization or outside the organization, but basically they are labeled data set. The last one, production, is not labeled. Basically the real customer video uploaded from the camera. So they are being send it over to the Ray service and doing the prediction and inference.
Okay. And you said, like before you decided to store the entire video data set on this persistent disk, you were doing something else. Could you just describe like what optimization that allowed for?
Yeah, the entire video data set basically means the entire data set on the validation data set, the regression data set. That's the biggest one we have, yeah.
Yeah, so I have a question, like how you do the experimentation, like A/B testing? How you decide that you retrain a model and it is better than you deployed?
Yeah, thanks. So A/B testing, we natively use Istio. So we kind of basically implemented the layer on top of Ray Anyscale to use Istio native A/B testing kind of functionality.
So you mentioned that you're using Anyscale, right?
Yes.
So for training, are you using Ray Train?
Yes, we are.
And how are you doing validation? Is it part of training, or do you run like offline batch inference?
The validation is outside of the training. It's totally separated. Basically, training is kind of training, and the validation basically using the serving code to serve like like own validation data set.
And it only uses Ray data and Ray serve, or
Ray data, Ray serve, Ray train, and those are the core library, other than the Ray core, obviously. Yeah.
so you use Ray train while validation?
No, validation, we don't use Ray train. We use the Docker image that was, because it was a code, so we kind of, like on the validation side, we use a Docker image to do that, and it's outside of the Ray train, yeah.
Thank you.
All right, let's thank our speaker one more time. Thank you, Mike.
Thank you, everyone.